So that's all that we are going to learn from today's session. But before we end the session, so we are going to have a last activities. So our last activities, we're going to combine all the knowledge that we learned from today's session and also yesterday's session, so that we are able to come up with much more complete program. So we're just going to use this program that we created earlier. So here we have a calculator program with 4 functions. But in this program, as you can see that the program has a flaw. When the user want to run a function, they need to call it manually, and let's say plus, so it call plus, it run, then it can do plus operation. But then later on, let's say the user want to have multiply operation, then we need to change the program again, and instead of call plus, now we call multi function. So this is really not convenient for the user, because we need to change from time to time and again. So what we can do is we can use nested if function, where we introduce 4 conditions, 1 condition for each function. Let's say plus condition when it meet, let's say when the user enter plus, then the program will do plus operation, and when the user enter negative, the program will run subtract function. So first we receive input from the user. So I will name a variable name operator equal to input from the user, input the prompt, please enter the operator. So it will be plus, minus, multiplication, and division. So only 4 symbol will be accepted. So then after we receive the input from user, now we need to do the decision making for the program. So if we use this variable that we receive from the user, so operator, if operator equal to plus sign, so plus, then the program will call up the plus function. So plus function. But note that at the end of the program, it will print result. So with small letter r. And in plus function, or also in other function, we have return function, which is it return a value of result into the function. So we need to receive the value from the function, which we're going to store in this variable. So result equal to plus. So we're going to do the same thing to all for other 3 operator, but we're going to use next one is elif operator equal to, now it's negative sign, so we will call subtract function. So result equal to subtract open and close bracket, and then again, okay, you can just copy this line, and we just change the operator is now multiply, and it will call multi function. Then for the last operator is for division, so it will perform div function. Okay, we have 4 operators. But what else? What if the user enter other symbol? So we don't want the user enter other symbol. So if the user enter other symbol, we want to warn the user that they have a wrong operator. So we use else as a default value whenever the user enter the wrong thing. So else print a wrong operator. But before that, if we check here that, okay, we need to end all the else if function with double dot. Okay. So, okay. Now let's try run our program. So it will ask the user to enter the operator. Let's say we try to use negative operator for negative operation. So enter a number 23, 12.1. So the total value is 10.9. So it is correct. So but you can see here, what happened is, actually the program, after one operation, it stopped, and then we want to perform another calculation. We need to run it again. So this is really not convenient for the user. So what we can do is, we loop the program, and every time after we finish looping the program, we ask the user if they want to continue the program or not. So we want going to use while loop, while, and the condition. So let's say when the user enter when we ask the user whether they want to continue or not, we will save it in exit variable. So exit equal to input from the user, input, and the prompt, continue using calculator, and the y or n. So after the user will enter the y or n into the exit. Then up here, while exit, we want the program continue until the user insert n value. So when the user don't want to continue using, so you enter n value, then the program stop. So while the exit is not equal to n, not equal to n, so any other value, it will continue looping. So first, before we start do the looping, while looping, we need to initialize what the value contained in exit first. So exit is equal to y, and make sure that, okay, after y, double dot, and all the program that going to be under while loop block need to be indented. So select them all, then indented. So let's try it out. So we run, we enter operator, let's use multiplication. So enter a number, 2.3, 3.4. So the total is 7.81999. So now you see that the program asks the user whether they want to continue or not. So let's say I put y, then it repeat again. It asks they ask the user what operator they want to use. So let's say now I want to use minus. Enter a number. So let's say a number. So now you see it's going to do again and again until the user enter n. So this is really good, right? For our program, the user are able to use them over and over again until they no longer want to use it. But let's see, what if the user enter the wrong operator? Okay, let's say we test the things that we did before. So enter dot, enter a number. So you can see here, it mentioned that it used the wrong operator, but it still display the total. Why it display the total? Because the print, this print function is at the end of the program. So no matter what happened to the operator, is it right, is it correct or not, it will just print out the total. And the value that it print out is actually the value that has been stored before. So this is going to be make confused to the user. So if the wrong operator happened, we don't want to print out the total is what. So what we can do is, the idea is, we have to make some things to indicate that when operator is wrong, they don't have to print the total is something. So under else, we introduce a variable called error is 1. So whenever the error contain value 1, it means that error occur. So if the error occur, means we don't want to run this print the total is something. So we use if again. If error is not equal to 1, then print this. So any other value in error, it will run perfectly, but when we run else, then it will be a wrong operator, then the one value will be stored in error, then So the total will not be run. But at the top of the program, we need to initialize the value. So the value will be error is 0. So note that I'm not putting the value of error equal to 0 at the top one, but inside the while loop. This is very important because we need to reset again and again, so that when the program run for a new for new operation, so we reset the condition. And if the error occur, then it will enter value 1, then it will not run this program, but user want to continue use again, so we reset back the condition. So let's try the program. So we start the first and run again. So use plus and so we want to use a wrong operator. So let's put a bracket. So now enter a number. So you can see down here wrong operator, and so there's no longer the total is something. So if we continue using it, then we put a correct operator, then 23, 12. You see, it's appearing again. So this is much more robust program. But note that there's one more thing that actually can break our program. So let's try it again. So let's enter Y, and let's say here we use multiply operation, and then we enter a number. The first number is correct, it's a number. Then the second number we try to put a words or a string. So what happened? It will break our program. So this is not good. We don't want this thing to happen to our program. So what can we do is we need to tell the program how they behave when an error occurs. So when an error, this type of error, which is it should receive string, it should receive number, but the user enter a string. So how they're going to behave, we use try except function. And try except function need to be in while loop over the program. So while loop, we start here, try, double dot, and then we select all of the program, indent it, and then except. So except, here we don't want this kind of error, it is a value error. You can see that it's a value error. So except value error. So when value error occur, so the program will move to the except value occur, and how it will behave. So we want it behave, how we want the program to behave is, we want the program to mention to the user that, let's say, cannot enter string. So we say that the print, let's say we want to print only numbers are accepted. So like print only numbers are accepted. Okay, we need to first in front error only numbers are accepted. So let's try again our program. We use division, and then enter number, and 2, 1. So whenever this is happening, see our program not break. This is really important to have our program not to break. So if this is happening again and again, it will be really frustrated, and the program is not usable because it break whenever the user do some errors. So we need to make sure that the program are able to behave correctly whenever any error occur. So you see, the user can do another operation, minus 23, 1. So okay, let's stop using it. So let's see, the program is looping perfectly fine without no error. Even the error should be occurring there. Even the error is occurring there, the program are able to manage it. Okay, now it's look much more better program that we already been created. The program much more better. It able to handle error much more better. It able to loop the program. It able to do decision making for the user. But one more thing we need to take note, especially in this program, because the program we do is a calculator. So in math we know that numbers cannot be divided by zero. What happens if the number is divided by zero? It will be an error occur. So this is also the same thing. We cannot do a division by zero. Let's say we choose division and enter a number. Let's say we enter 3 and 0. What happened? It break our program again. So we don't want to use this. You can see the error code, 0 division error. So you need to do one more except here. So copy the except. See? Instead of value error, then enter 0 division error. So now we are telling the program how they're going to behave or how they're going to handle 0 division error. So print error dividing by 0. So try to run it again, and division 23 0. So error dividing by 0. So we can see now our program is really robust. It can handle all type of error perfectly without breaking the program. So this is what we want. So if the program cannot handle error, then it is hard for the user to use, because every time the error occur, then it will break the program. So we don't want to have this kind of things. Okay, now everything is perfect for our program. But one thing we almost forget is actually at the end here, if we use the program, let's say plus 2 4. Okay, we do some errors, so like do it again, plus 2 3. The total is 5. Continue using to the calculator. Then let's say I say n. Oh, but it's still looping again. So why this is happening? This is because we forgot to mention that up here we mentioned it only capital letter N is accepted as no. But we want also to receive small letter, because we don't want to we want to have a freedom to the user. So for the condition, it's not a case sensitive. So here, what we can do is like exit dot upper. So basically, whatever input the user insert, it will change to upper letter. So it's much more better. And let's try run the code again. Let's see. Operator plus 23 12. Okay, let's say enter n. Now it break the program. But one last thing, we want to make sure that our program is clean and easier for the user to use. So what I mean by it's not really clean here is, let's say we use plus operation, okay, it's an error there. Okay, one operator, okay, plus 23, and we do another, okay, wrong again, continue using it, and division 23 by 1. Okay, what you notice here? We notice that the previous output is also being displayed in the terminal. So if we run the program 10 times, there is 10 previous output there. So we don't want to have this. It make more confused to the user, and also it doesn't the program doesn't look clean in the terminal. So what we need to include here is to clear the output every time after we finish doing the calculation. So before this, we learn about clear output. So we take from the previous program. If we don't, you can just write it, but I just copy it, so it's much more faster. Now, at the end of every calculation, I want to clear the screen. So at the end one, after I ask the user whether he want to continue or not, so I will clear the screen. So clear output. So let's try use our program. Plus 23 3. So whether we want to continue, yes. So what happened? We see that the operator returned to the terminal clear all the previous display, the previous output. So when we run 100 times, 200 times, how many times, it doesn't make the terminal messy. It will clean again and again, and to make the program much more user friendly. It will not confuse the user, and it's easier for them to use. So that's all for today. We learn a lot of things. So today we learn about the function, we learn about loop, we learn about decision making, and we also learn about try accept. And at the end of today's session, we also try to create a much more robust and complete program. So I hope that all of you can try on your own and try something different. Like here, I try doing calculator. You can try other things. Something that you imagine, like say before this, you want to do this, but you never learn programming. So now you learn programming, try to do it. So learn on your own, and also look at the lecture note. You see that there is link inside the lecture note. So go through the link. You can go to the website and learn a lot more new things, a lot of other things in program. There's a lot of things that's not been covered in our session because we have really limited time, but this doesn't limit your capabilities in programming. What you can do is go on your own, try on your own, and learn more, explore more. This is really good for you. And maybe because maybe a lot of you are really interested in programming, so please try and sharpen your skill. So we're going to meet again in our briefing for competition later on. Thank you for today. Thank you for joining me in this session number 2 and the last session for Hello World. Thank you.